So you just landed a job interview at a very big tech company. Isn't that amazing? The position is Android developer. Your language of choice is Kotlin. The resources for job interview questions using Kotlin on the internet non-existent. That's why these videos are here. Of course, you're going to study many data structures for this interview. You must. Among them is the linked list. In the previous videos, I explained how to work with the linked list, how to create one, how to add the common operations for a linked list, like removing values, adding values. In this video, I'm going to show you the common interview questions that have to do with the linked list and how to do them with Kotlin. Now, the elephant in the room, of course, is that I am not using an IDE, I am using the terminal. Why, how, what's going on? Maybe for a later video, but it's been my personal goal to move away from the IDE where I can, just to see if I could. So these one-off programs that you write, just a linked list, just some operations, 3-4 classes, you don't really need an IDE. So I'm trying to go away from that. This is the effort that you see here. So the first question is going to be reversing a linked list. You hear about this a lot, that you don't need to know it. Oh, who knows how to do it? It's super simple. Just memorize the thing. Just as a recap, this is where we left off in the previous episodes. We added the insert, pop, remove last, node at, append, push. These are the common operations for a linked list. And you have the node class, which has this structure. And then you have the runner class, where we will enter the solution for this problem. So we're going to start off by defining a extension function on the linked list, right? It's going to be a type T, so whatever the node is, it's going to work. Print in reverse. What it does is takes the first node and calls print in reverse on that node. So a straightforward way to do this is using recursion. Recursion allows you to build a call stack. So you need to call the print statements as the call stack is unwinding. So you build the call stack of things that need to be printed. As it's finishing, it reaches the base case, starts to unwind, and then you print the stuff. So this function forwards the traversing of the list to a recursive function that we have not defined yet. This traversing of the list is going to be happening through a recursive function. It goes through the list node by node. This is the forwarding of that call to that function. That function is going to be written in the node class. So it's an extension function again of type any, of type T, and it's also called print in reverse. So what this function does is call itself on the next node. So you started off with node at 0, and now it calls itself on the next one and the next one. So the terminating condition here is sitting inside the null safety operator. So if there is no next node, and it's null, that's when the function stops. And then you need to print because you've started to unwind the call stack. So any code that comes after the recursive call is called only after the base case triggers, meaning after the recursive function hits the end of the list. So first we check if we reach the end of the list. That's the beginning where we reverse print. And we'll not add an arrow here, we'll add one when there is a value, so that the first one doesn't get an arrow behind it. It's just for pretty printing. Then as the recursive statements unravel, the node data gets printed. Now we'll head off to the runner class, initiate a list, initialize a list, I mean. You can add, you can insert, you can push, whatever you want. Just put 5 or 6 values into the list, different values, whatever. Print the original list and then print it in reverse, run the thing, watch for the output, and is inverted. Okay, great. But I don't like how there's 2 dashes in the second line, so let's go to the node class and remove 1 dash. And that'll be it for reversing a linked list in the first way. Another question would be, get me the middle value from a linked list. How do you do that? Well, you can define another extension function, let's say get middle value on the linked list itself, which is going to return a node, because that's what the value in each of the linked list items is. It's a node. So one of the solutions is to have two references traversing down the nodes of the list where one is twice as fast as the other. So when the faster reference reaches the end, the slower reference will be in the middle. Pretty smart. I didn't come up with this, of course. This is from the book Data Structures and Algorithms in Kotlin by Ray Wenderlich. I'll link to it in the description of the video below so you can become as smart as I am when you read the book. And inside the while declaration, you bind the next node to the fast reference. If there is a next node, you update fast to the next node of fast. So you're effectively stepping down the list twice. Slow is updated only once. Apparently, this is called the runner technique. Who knew? Now we're just gonna try and get the middle value here, print it along with the other stuff. Let's just add some carriage returns here so it could look prettier. Where is the code for all of this? There is no code for all of this. You have to type it yourself to learn it. Okay, now we get to the good stuff. No, I'm kidding, it's the same stuff. So here's another approach to reversing a linked list. You need to visit each node and update the next reference to point in the other direction. Now this one can be hard because you need references to head and tail, and you're in an extension function and you need to keep track of the head and tail of multiple nodes. So you don't have a head and tail here in the extension function. You're not sitting inside linked list class. You're sitting inside the linked list extension function. You can easily do this without that stuff that I already mentioned by just using a recursive function that goes to the end of the list and then starts copying back the nodes when it is unfolding the call stack. So as you're returning, you copy into a new list and then you return that list. That would have been, that becomes a reversal. So here's how that would look like. It's an extension function called add in reverse, takes a list, takes a node where to start at. First, you get the next node of the list, starting with the one you received as a parameter. And if there's a following node, you recursively call the same function. So if the next thing, the next node is not null, you add in reverse again. So when you reach the end, you start adding nodes in reverse with list.append. And how do you use this? Well, you can have another extension function called reverse. So what it does is create a new list and then fills it with nodes by calling add in reverse. And of course, it passes the starting node, the head, so that it knows where to start. And in the end, you will get back a list that is reversed. Return a result. All right. Now we head back to the runner. Let's comment this stuff out and try it. Print the original list, print the version that's reversed, run it, and you get back original is 1, 2, 3, whatever, reversed is that. So that is it for linked list operations. These are the kind of interview questions you might get. I don't know if you will, but this is the one I hear about the most. Reversing a linked list, finding the middle node. You're probably going to get some problem that deals with this problem inside of it. It's probably not going to say, hey, here's a linked list, reverse it. No, it's going to probably say there's a list of students and you need to get the order of their names, something, and you need to store it in a linked list. It's probably going to be like that, but who knows? Yeah. The next one is probably going to be about different data structures. I'm kind of sick of linked lists. Maybe we'll do tries. Let me know what you think about this or other videos and what data structure you want to see next. See you in the next one.